around 2500 BC. Thousands of workers carved, moved, and positioned over 2 million limestone blocks to build what would become the last standing wonder of the ancient world. A structure so precise that its base is level within 2 centimeters across 13 acres and whose sides align to true north within 0.15 degrees. Imagine discovering that this level of accuracy matches what we achieve today with laser technology and modern engineering. Picture this. The ancient Egyptians supposedly accomplished this feat using copper chisels, wooden sleds, and no knowledge of the wheel or pulley. But here's where it gets even more fascinating. The deeper we look at the Great Pyramid of Giza, the more we find mathematical relationships, astronomical alignments, and engineering mysteries that challenge everything mainstream archaeology tells us about humanity's capabilities 4.5 millennia ago. Before we dive deeper, comment below. Where in the world are you watching from? Drop your country in the comments right now. Stand at the base of the Great Pyramid and you're looking at 2.3 million stone blocks. Each block weighs between 2 and 15 tons on average. And the granite blocks in the King's Chamber, transported from Aswan, over 500 miles away, weigh up to 80 tons each. Now picture this. The outside surface stones were cut within 0.01 inch of being perfectly smooth and assembled at nearly perfect right angles, off by only 0.001 inch. Think about what that means for a moment. Modern technology still cannot place such heavy stones with greater accuracy than this. We're talking about blocks weighing as much as multiple cars, carved and positioned with tolerances that would challenge a modern machinist working with precision equipment. But this is where the story takes a surprising turn. When engineers analyze the mathematical proportions encoded in the pyramid's dimensions, they find something remarkable. If you divide the perimeter of the pyramid's base by twice its height, you get 3.14, the mathematical constant pi, accurate to 2 decimal places. The ancient Egyptians supposedly didn't have formal knowledge of pi, yet there it is, embedded in the world's most famous structure. And here's where it gets even more fascinating. The ratio of the pyramid's height to half its base gives you 1.618. The golden ratio, known as phi, also accurate to multiple decimal places. Mainstream archaeologists argue these are coincidences, accidents of practical construction choices rather than intentional design. And they raise some valid points. With enough measurements, you can find numerical relationships in any structure. But then we have the astronomical alignments. The 3 pyramids at Giza don't just sit randomly on the plateau. They mirror the pattern of the 3 stars in Orion's belt, rotated exactly 180 degrees. The angular distances between the pyramids match the angular distances between the stars with remarkable precision. And no matter how you approach it, one thing remains undeniable. Someone 4,500 years ago possessed geometric knowledge, surveying capabilities, and organizational capacity that seems impossibly advanced for Copper Age civilization. If this evidence is new to you, hit the like button right now. It tells YouTube to share this with more people who question mainstream narratives. Seriously, pause and like this video. Now let's talk about something even stranger, the interior temperature. Walk into the King's Chamber on the hottest day of summer, and you'll find the temperature holds constant at 20 degrees Celsius, which equals 68 degrees Fahrenheit. This matches the average temperature of Earth itself. How? The structure somehow regulates its internal climate through passive thermal mass and air circulation systems built into the design. Scientists have documented varying temperatures in different chambers, suggesting an engineered thermodynamic system where some chambers absorb and release heat to stabilize others. This isn't just a pile of rocks. This is sophisticated climate engineering, and this is the part mainstream archaeology can't easily explain: the precision cutting. The pyramid contained cornerstones that had balls and sockets built into them, which subjected the structure to expansion and contraction movements from heat and cold, as well as from earthquakes and other natural phenomena. Inside the pyramid sits a granite chest too large to have been carried through the narrow passages, meaning it was placed during construction before the chambers were sealed. When modern archaeologists tried to replicate ancient granite cuts using copper saws and sand as an abrasive, the method technically worked. But incredibly slowly, the copper wore down faster than the granite. Yet the ancient Egyptians somehow mass-produced these precise granite cuts across thousands of blocks. But here's where it gets even more fascinating. Just a few hundred feet from the Great Pyramid sits the Great Sphinx, a massive limestone sculpture carved from bedrock. According to mainstream Egyptology, it was built around the same time as the pyramids, roughly 2,500 BC, during the reign of Pharaoh Khafra. But in 1990, geologist Robert Schoch examined the weathering patterns on the Sphinx and its surrounding enclosure and made a controversial claim. The erosion patterns, he argued, were caused by prolonged rainfall, not wind and sand. Picture deep vertical channels running down the limestone walls, the kind formed when water runs over stone for centuries. Here's the problem. Egypt hasn't experienced that kind of sustained rainfall since before 5000 BC. And more realistically, not since around 10,000 BC Schoch conducted seismic studies measuring the depth of weathering beneath the Sphinx enclosure floor. His analysis suggested a minimum age of 7,000 years, but more realistically closer to 12,000 years ago. This discovery could rewrite everything we thought we knew about ancient Egypt. Pause and comment your answer. Could the Sphinx really date back 12,000 years? Comment 1 if you think yes, or 2 if you think the conventional dating is correct. I read every comment and replied to the most interesting theories. Mainstream geologists pushed back hard against Schoch's findings. They pointed to alternative explanations: wind erosion, salt crystallization from groundwater seeping through the limestone, and Nile flooding that could have produced similar patterns. Egyptologist Mark Lenner argued that the Sphinx enclosure fits perfectly into the overall layout of the Giza complex, and that limestone quarried from the Sphinx enclosure was used in nearby buildings dated to Khafra's reign. And here's where it gets even more fascinating. Geoscientist Jørn Christiansen suggested that some erosion occurred before the Sphinx was even carved, as water seeped through natural fissures in the limestone over millions of years. This could make the weathering look far more ancient than it actually is. But then we have Schoch's counterargument. He points out that the erosion patterns aren't evenly distributed across the Sphinx enclosure. They're concentrated in areas that would have been exposed to running water, not just atmospheric moisture. If salt crystallization or wind were the primary causes, the weathering should appear uniform across all exposed surfaces. It doesn't. And this is the part mainstream archaeology can't easily explain. Why do the vertical solution channels follow pre-existing joints and faults in the bedrock, exactly as you'd expect from prolonged water flow? Now picture this. Just south of the Giza Plateau lie the mastaba tombs, carved from the same limestone during the 4th dynasty. These tombs show minimal erosion compared to the Sphinx. Schoch argues. This proves that rainfall alone hasn't significantly degraded monuments in Egypt. unless they were exposed for far longer than conventional dating, allows Hawass counters that the tombs weren't built in a natural catchment area where water runoff would accumulate. The debate continues, with both sides presenting compelling geological evidence. Here's where the story takes a surprising turn. If the Sphinx really does date back 10 to 12,000 years, then who built it? Mainstream archaeology tells us that sophisticated civilization in Egypt began around 3100 BC with the unification of Upper and Lower Egypt. Before that, we see scattered pre-dynastic settlements with simple tools, pottery, and no evidence of monumental architecture. Imagine discovering that a highly advanced civilization existed in Egypt 7,000 years before the pyramids, possessed stone carving technology sophisticated enough to create the largest monolithic statue in the ancient world, and then vanished without leaving behind cities, writing systems, or any other archaeological footprint. That's the implication of the water erosion hypothesis. And it's exactly why mainstream archaeologists resist it so strongly. But here's where it gets even more fascinating. Graham Hancock and Robert Bauval have connected the Sphinx dating controversy to a broader pattern. They point to the Orion correlation we discussed earlier and suggest that the entire Giza complex was designed as a terrestrial map of the heavens as they appeared around 10,500 BC, using astronomical software to reverse the precession of the equinoxes. They showed that the three pyramids aligned perfectly with Orion's belt in that specific epoch. At the same time, the Sphinx, facing due east, would have gazed directly at the constellation Leo rising on the vernal equinox. The Age of Leo, a lion monument, watching its celestial counterpart rise over the horizon. Mainstream archaeologists argue this is cherry-picking data to support a predetermined conclusion. And they raise some valid points. Astronomical alignments can be found in almost any ancient structure if you look hard enough across different time periods. But then we have the cumulative weight of evidence. The water erosion, the astronomical alignments, the mathematical encoding, the precision engineering, and the sophisticated thermodynamic systems. And no matter how you approach it, one thing remains undeniable. The Giza complex demonstrates capabilities that push the boundaries of what we believe was possible in the Bronze Age. So what does this mean for humanity's forgotten history? If a civilization advanced enough to build the Sphinx existed 12,000 years ago, what happened to them? Some researchers point to the Younger Dryas impact hypothesis, a proposed cosmic event around 10,800 BC that triggered rapid climate change, flooding, and potentially wiped out advanced societies across the globe. Picture massive floods submerging coastal settlements where most ancient populations would have lived, erasing archaeological evidence beneath hundreds of feet of water. The survivors would have been scattered, their knowledge fragmented, their monuments weathered beyond recognition. This flips everything we thought we knew about human civilization on its head. Instead of a linear progression from simple hunter-gatherers to complex societies, we might be looking at cycles, at advanced civilizations rising, falling, and leaving behind only their most durable monuments as silent testimony. The pyramids might not represent the beginning of Egyptian sophistication, but the inheritance of far older knowledge, the mathematical constants, the astronomical alignments, and the precision engineering might be echoes of a lost scientific tradition, passed down through myth and carefully guarded by priesthoods. Mainstream archaeologists are right to demand extraordinary evidence for extraordinary claims. The burden of proof lies with those proposing radically earlier dates for the Sphinx and a lost advanced civilization. We still lack the archaeological evidence, the cities, the tools, the writing systems, the human remains that would conclusively prove such a civilization existed, but we do have erosion patterns that multiple geologists interpret as water-induced, astronomical alignments that point to specific ancient epochs, and engineering achievements that continue to baffle modern experts. If you found this compelling, hit like, subscribe, and drop your thoughts below. This channel is dedicated to exploring evidence mainstream conversations often overlook.